Peirce regarded inductive processes as rather marginal to the acquisition of knowledge. In his words, quote, induction has no originality in it, but only tests a suggestion already made, end quote. To understand how knowledge is acquired, in the rationalist view that Peirce outlined, we must penetrate the mysteries of what he called abduction, and we must discover that which, quote, gives a rule to abduction and so puts a limit upon admissible hypotheses, end quote. Peirce maintained that the search for principles of abduction leads us to the study of innate ideas, which provide the instinctive structure of human intelligence. But Peirce was no dualist in the Cartesian sense. He argued, not very persuasively in my opinion, that there is a significant analogy between human intelligence with its abductive restrictions and animal instinct. Thus, he maintained that man discovered certain true theories only because his instincts must have involved from the beginning certain tendencies to think truly about certain specific matters. Similarly, you cannot seriously think that every little chicken that is hatched has to rummage through all possible theories until it lights upon the good idea of picking up something and eating it. On the contrary, you think that the chicken has an innate idea of doing this. That is to say, that it can think of this, but has no faculty of thinking anything else. But if you're going to think every poor chicken endowed with an innate tendency toward a positive truth, why should you think to man alone this gift is denied? No one took up Peirce's challenge to develop a theory of abduction to determine those principles that limit the admissible hypotheses or present them in a certain order. Even today, this remains a task for the future. It is a task that need not be undertaken if empiricist psychological doctrine can be substantiated. Therefore, it is of great importance to subject this doctrine to rational analysis, as has been done in part in the study of language. I would like to repeat that it was the great merit of structural linguistics, as of Holleyan learning theory in its early stages and of several other modern developments, to have given precise form to certain empiricist assumptions. In contrast, the account of language acquisition presented by B.F. Skinner in his Verbal Behavior seems to me either devoid of content or clearly wrong, depending on whether one interprets it metaphorically or literally. See my review of this book in Language, Volume 35, Number 1. It is quite appropriate when a theory is disproven in a strong form to replace it by a weaker variant. However, not infrequently, this step leads to vacuity. The popularity of Skinner's concept of reinforcement after the virtual collapse of Holleyan theory seems to me a case in point. Note the Skinnerian concepts can be well defined and can lead to interesting results in a particular experimental situation. What is at issue is the Skinnerian extrapolation to a wider class of cases. Another example appears in K. Salzinger's The Problem of Response Class in Verbal Behavior, in Research in Verbal Behavior and Some Neurophysiological Implications. Salzinger argues that George Miller is not justified in criticizing learning theory for its inability to explain linguistic productivity. That is, the ability of a speaker to determine of a sequence of words that he or she has never heard, whether or not it is a well-formed sentence and what it means. The defect can be overcome, he argues, by making use of the notion of response class. True, it cannot be that each response is reinforced, but the class of acceptable sentences constitutes a response class, like the set of bar presses in a particular Skinnerian experiment. Unfortunately, this is empty verbiage until the condition that defines membership in this class is established. If the condition involves the notion generation by a given grammar, then we are back where we started. Salzinger also misconstrues the attempts to provide an experimental test that will distinguish grammatical from ungrammatical strings. He states that such tests have failed to confirm such a failure, and that this division concludes, apparently, that the distinction does not exist. And obviously the failure indicates nothing more than the tests were ineffective. One can invent innumerable tests that would fail to provide some given classification. Surely the classification itself is not in question. Thus, Salzinger would agree, quite apart from any experimental test that might be devised, that the sentences of this footnote share an important property that does not hold the set of strings of words formed by reading each of these sentences, word by word, from right to left. Where this step has been taken, the inadequacy of the postulated mechanisms has been clearly demonstrated, and in the case of language at least, we can even begin to see just why any methods of this sort must fail. For example, because they cannot in principle provide for the properties of deep structures and the abstract operations of formal grammar. Speculating about the future, I think it is not unlikely that the dogmatic character of the general empiricist framework and its inadequacy to human and animal intelligence will gradually become more evident as specific realizations such as taxonomic linguistics, behaviorist learning theory, and the perception models. For discussion of such systems and their limitations, see Minsky and S. Papert, Perceptions and Pattern Recognition. But as we learn more about human and animal intelligence, and as that becomes more evident as specific realizations such as taxonomic linguistics, behaviorist learning theory, and the perception models, heuristic model methods, and general problem solvers of the early enthusiasts of artificial intelligence, or AI, are successfully rejected on empirical grounds when they are made precise on grounds of vacuity when they are left vague. And assuming this projection to be accurate, it will then be possible to undertake a general study of the limits and capacities of human intelligence to develop a logic of abduction. Modern psychology is not devoid of such initiatives. The contemporary study of generative grammar and its universal substructure and governing principles is one such manifestation. Closely related is the study of the biological basis of human language, an investigation to which Erich Lindbergh has made substantial contributions. See E. H. Lindbergh, Biological Foundations of Language. Of course, it is tempting to see a parallel development in the very important work of Piaget and others interested in the genetic epistemology, but I am not sure that this is accurate. It is not clear to me, for example, what Piaget takes to be the basis for the transition from one of the stages that he discusses to the next, higher stage. There is furthermore a possibility suggested by recent work of Mailer and Bever that the deservedly well-known results on conversation in particular may not demonstrate successive stages of intellectual development in the sense discussed by Piaget and his co-workers, but something rather different. See Mailer and Bever in the Journal of Science titled Cognitive Capacities of Young Children. If the preliminary results of Mailer and Bever are correct, then it would follow that the final stage in which conservation is properly understood was already realized at the very early period of development. Later, the child develops a heuristic technique that is largely adequate, but that fails under the conditions of the conservation experiment. Still later, he adjusted this technique successfully and once again makes the correct judgments in the conservation experiment. If this analysis is correct, then what we are observing is not a succession of stages of intellectual development in Piaget's sense, but rather slow progress in bringing heuristic techniques into line with general concepts that have always been present. These are interesting alternatives. Either way, the results may bear in important ways on the topics that we are considering. Still more clearly to the point, I think, are the developments in comparative ethology over the past 30 years and certain current work in experimental and physiological psychology. One can cite many examples. For example, in the latter category, the work of Bauer suggesting an innate basis for the perceptual constancies. Studies in the Wisconsin Primate Laboratory on complex innate releasing mechanisms in several monkeys. The work of Hubel, Barlow, and others on highly specific analyzing mechanisms in the lower cortical centers of mammals, and a number of comparable studies of lower organisms, for example, the beautiful work of Litvin and his associates on frog vision. There is now good evidence from such investigations that perception of line, angle, motion, and other complex properties of the physical world is based on innate organization of the neural system. In some cases, at least, these built-in structures will degenerate unless appropriate stimulation takes place at an early stage in life. But although such experience is necessary to permit the innate mechanisms to function, there is no reason to believe that it has more than a marginal effect on determining how they function to organize experience. Furthermore, There is nothing to suggest that what has been so far discovered is anywhere near the limit of complexity of innate structures. The basic techniques for exploring the neural mechanisms are only a few years old, and it is possible to predict what order of specificity and complexity will be demonstrated when they come to be extensively applied. For the present, it seems that most complex organisms have highly specific forms of sensory and perceptual organization that are associated with the Umwelt and the manner of life of the organism. There is little reason to doubt that what is true of lower organisms is true of humans as well, particularly in the case of language. It is natural to expect a close relation between innate properties of the mind and features of linguistic structure, for the invention of language, after all, has no existence apart from its mental representation. Whatever properties it has must be those that are given to it by the innate mental processes of the organism that has invented it, and they invents it anew with each succeeding generation, along with whatever properties are associated with the conditions of its use. Once again, it seems that language should be, for this reason, a most illuminating probe with which to explore the organization of mental processes. Turning to comparative ethology, it is interesting to note that one of its earliest motivations was the hope that through the investigation of the a priori of the innate working hypotheses presented in subhuman organisms, it would be possible to shed light on the a priori forms of human thought. This formulation of intent is quoted from an early and little-known paper by Conrad Lorenz, C.K. Lawrence, Kant's Lehre vom Apriorischen in Gewinnwaltiger Biologie. That's in Blatter für Philosophie. That's a German paper. Nevertheless, Lawrence goes on to express views very much like those that Peirce had expressed a generation earlier. He maintains, one familiar with the innate modes of reaction of subhuman organisms can readily hypothesize that the a priori is due to hereditary differentiations of the central nervous system, or the CNS as you may be commonly familiar with, which have become characteristic of the species, producing hereditary dispositions to think in certain forms. Most certainly David Hume was wrong when he wanted to derive all that is a priori from that which the senses supply to experience, just as wrong as Wundt or Helmholtz, who simply explain it as an abstraction for preceding experience. Adaptation of the a priori to the real world has no more originated from experience than adaptation of the fin of the fish to the properties of water, just as the form of the fin is given a priori prior to any individual negotiation of the young fish with the water, and just as it is this form that makes possible this negotiation, so it is also the case with our forms of perception and categories in their relationship to our negotiation with the real external world through experience. In the case of animals, we find limitations specific to the forms of experience possible for them. We believe we can demonstrate the closest functional and probably genetic relationship between these animals a priori and our human a priori. Contrary to David Hume, we believe, just as did Kant, that a pure science of innate forms of human thought, independent of all experience, is possible. Peirce, to my knowledge, is original and unique in stressing the problem of studying the rules that limit the class of possible theories. Of course, his concept of abduction, like Lawrence's is biological a priori, has a strongly Kantian flavor and all derived from the rationalist psychology that concerned itself with the forms, the limits, and the principles that provide the sinews and connections for human thought that underlie that infinite amount of knowledge of which we are not always conscious, of which Leibniz spoke. It is therefore quite natural that we should link these developments to the revival of philosophical grammar, which grew from the same soil as an attempt, quite fruitful and legitimate, to explore one basic facet of human intelligence. In recent discussion, models and observations derived from ethology have frequently been cited as providing biological support, or at least analog, to new approaches to the study of human intelligence. I cite these comments of Lawrence's mainly in order to show that this reference does not distort the outlook of at least some of the founders of this domain of comparative psychology. One word of caution is necessary, however, in referring to Lawrence, now that he has been discovered by Robert Ardrey and Joseph Alsop and popularized as a prophet of doom. It seems to me that Lawrence's views on human aggression have been extended to near absurdity by some of his expositors. It is no doubt true that there are innate tendencies in the human psychic construction that lead to aggressiveness under specific social and cultural conditions. But there is little reason to suppose that these tendencies are so dominant so as to leave us forever tottering on the brink of a Hobbesian war of all against all, as incidentally Lawrence at least is fully aware, if I read him rightly. Skepticism is certainly in order when a doctrine of man's inherent aggressiveness comes to the surface in a society that glorifies competitiveness in a civilization that has been distinguished by the brutality of the attack that it has mounted against less fortunate peoples. It is fair to ask to what extent the enthusiasm for this curious view of man's nature is attributable to fact and logic, and to what extent it merely reflects the limited nature of that is attributable to which the general cultural level has advanced since the days when Clive and the Portuguese explorers taught the meaning of true savagery to the inferior races that stood in their way. In any event, I would not want what I am saying to be confused with other entirely different attempts to revive a theory of human instinct. What seems to me pertinent in ethology is its attempt to explore the innate properties that determine how knowledge is acquired and the character of this knowledge. Returning to this theme, we must consider a further question. How did the human mind come to acquire the innate structure that we are led to attribute to it? Not too surprisingly, Lawrence takes the position that this is simply a matter of natural selection. Of course, Peirce offers a rather different speculation, arguing that nature fecundates the mind of man with ideas which, when these ideas grow up, will resemble their father, nature. Man is provided with certain natural beliefs that are true because certain uniformities prevail throughout the universe, and the reasoning mind is itself a product of this universe. These laws are thus by logical necessity incorporated in his own being. Here, it seems clear that Peirce's argument is entirely without force, and that it offers little improvement over the pre-established harmony that it was presumably intended to replace. The fact that the mind is a product of natural laws does not imply that it is equipped to understand these laws or to arrive at them by abduction. There would be no difficulty in designing a device, say programming a computer, for example, that is a product of natural law, but that given data will arrive at any arbitrary, absurd theory to explain these data. In fact, the processes by which the human mind achieved its present stage of complexity and its particular form of innate organization are a total mystery. As much as so, the analogous questions about the physical or mental organization of any other complex organism. It is perfectly safe to attribute this development to natural selection, so long as we realize there is no substance to this assertion, that it amounts to nothing more than a belief that there is some naturalistic explanation for these phenomena that will eventually be available to us. The problem of accounting for evolutionary development is in some ways rather like that of explaining successful abduction. The laws that determine possible successful mutation in the nature of complex organisms are as unknown as the laws that determine the choice of hypotheses. It has been argued on statistical grounds through comparison of the known rate of mutation with the astronomical number of imaginable modifications of chromosomes in their parts that such laws must exist and must vastly restrict the realizable possibilities. See the papers by Eden, Schutzenberger, and Gavaden in Mathematical Challenges to the Neo-Darwinian Interpretation of Evolution in the Vistar Symposium monograph. With no knowledge of the laws that determine the organization and structure of complex biological systems, it is just as senseless to ask what the probability is for the human mind to have reached its present state, as it is to inquire to the probability that a particular physical theory will be devised. And as we have noted, it is idle to speculate about laws of learning until we have some indication of what kind of knowledge is attainable. In the case of language, some indication of the constraints on the set of potential grammars. In studying the evolution of mind, we cannot guess as to what the extent is of physically possible concerning alternatives to, say, transformational generative grammar for an organism meeting certain other physical conditions characteristic of humans. Conceivably, there are none, or very few, in which case talk about evolution of the language capacity is beside the point. The vacuity of such speculation, however, has no bearing one way or another on those aspects of the problem of mind that can be sensibly pursued. It seems to me that these aspects are, for the moment, the problems illustrated in the case of language by the study of the nature, the use, and the acquisition of linguistic competence. There is one final issue that deserves a word of comment. I have been using mentalistic terminology quite freely, but entirely without prejudice, as to the question of what may be the physical realization of the abstract mechanisms postulated to account for the phenomena of behavior or the acquisition of knowledge. We are not constrained, as was Descartes, to postulate a second substance when we deal with phenomena that are not expressible in terms of matter in motion. Nor is there much point in pursuing the question of psychophysical parallelism in this connection. It is an interesting question whether the functioning and evolution of human mentality can be accommodated within the framework of physical explanation as presently conceived, or whether there are new principles now unknown that must be invoked, perhaps principles that emerge only at a higher level of organization that can now be submitted to physical investigation. We can, however, be fairly sure that there will be a physical explanation for the phenomena in question, if they can be explained at all, for an uninteresting terminological reason, namely that the concept of physical explanation will no doubt be extended to incorporate whatever is discovered in this domain, exactly as it was extended to accommodate gravitational and electromagnetic force, massless particles, and numerous other entities and processes that would have offended the common sense of earlier generations. But it seems clear that this issue not delay the study of the topics that are now open to investigation, and it seems futile to speculate about the matters so remote from present understanding. I have tried to suggest that the study of language may very well, as was traditionally supposed, provide a remarkably favorable perspective for the study of human mental processes. The creative aspect of language use, when investigated with care and respect for the facts, shows that current notions of habit and generalization as determinants of behavior or knowledge are quite inadequate. The abstractness of linguistic structure reinforces this conclusion, and it suggests further that in both perception and learning, the mind plays an active role in determining the character of the acquired knowledge. The empirical study of linguistic universals has led to the formulation of highly restrictive and, I believe, quite plausible hypotheses concerning the possible variety of human languages, hypotheses that contribute to the attempt to develop a theory of acquisition of knowledge that gives due place to intrinsic mental activity. It seems to me, then, that the study of language should occupy a central place in general psychology. Surely, the classical questions of language and mind receive no final solution, or even the hint of a final solution, from the work that is being actively pursued today. Nevertheless, these problems can be formulated in new ways and seen in a new light. For the first time in many years, it seems that there is some real opportunity for substantial progress in the study of the contribution of the mind to perception and the innate basis for acquisition of knowledge. Still, however, in many respects, we have not made the first approach to a real answer to the classical problems. For example, the central problems relating to the creative aspect of language use remain as inaccessible as they have always been, and the study of universal semantics, surely crucial to the full investigation of language structure, has barely advanced since the medieval period. Many other critical areas might be mentioned where progress has been slow or non-existent. Real progress has been made in the study of the mechanisms of language, the formal principles that make possible the creative aspect of language use, and that determine the phonetic form and semantic content of utterances. Our understanding of these mechanisms, though only fragmentary, does not seem to me to have real implications for the study of human psychology. By pursuing the kinds of research that now seem feasible, and by focusing attention on certain problems that are now accessible to study, we may be able to spell out in some detail the elaborate and abstract computations that determine, in part, the nature of percepts and the character of the knowledge that we can acquire, the highly specific ways of interpreting phenomena that are, in large measure, beyond our consciousness and control, and that may be unique to humankind.